happened. Can you all hear me online? Maybe what I should do here. Let's close that. Yep, you can hear me online. Okay. Oh, that's not good. Lag again. That's not good. Oh my God. What's going on there? This isn't great, is it? Okay, what can we do here? I don't really know. Who's like pretty confident to call audiovisual for me while I try and sort this out? It's just a UNSW phone number. Is anyone able to volunteer? No? Say no. This is the real test of the, you're ready to call? What's the UNSW, yeah, round of applause. What's the UNSW base number? UNSW 9385. You got this. 9385 4888. Is that to amp us up, the music? Yeah, and say science theatre, none of the projectors are working for an external computer. They need to come straight away. You shouldn't need to, but maybe. This is horribly, you know, I can't even begin to tell everyone how long I spent trying to get this room fixed over the break. And then, what's some alternative? What can we do here? What we might have to do. The projectors aren't working. Can you just, sorry, yeah. Sorry, can you just please send someone to the theatre? The projectors just aren't working. Yeah, the projectors aren't working with an external HDMI input. It's the long-standing issue with this room. Yeah, a Mac. Yeah, but I spent like weeks fixing this and this room was working last week. Yeah, thank you. You don't take a photo of this. This is my nightmare. Well, let's see. Well, let's problem solve. One thing we could do is everyone could open the YouTube video. But that's awful. Okay, someone's coming to try something, and AV are coming. What we can do, why don't we do this? So the second half of the lecture content is about teamwork. It's not about JavaScript. So why don't we start with that content, and we're just going to have to use my luxurious voice as your material, and you can follow along the slide PDFs. Does that make sense? And I'll follow along with them, and we'll just do our best with that. Did I upload the slide PDFs for today's lectures onto WebCMS? Let's have a look. PDFs. No, I didn't. So let me do that. Oops. Okay, let me do here and here. Let's have a look here. Okay. All right, so if you go to WebCMS and you go to the, I'm going to have to do it here, I guess. More inputs, internal computer, because I can do this. Oh God, I apologize. This was all meant to be fixed, so, okay. Lecture, stuff, PDFs. No, this is the internal computer, which I can't actually really use. Okay. No, not this one. I want... All right. Yeah, today ain't slaying, that's for sure, Mark, online. Okay, so I think what I'm going to have to do is I've got the lecture slides on the internal computer, which are on the projector, and I've got the lecture slides on my MacBook, which are being streamed online, and I'm going to have to keep them in sync. But we'll try that. Does that sound good? Okay. Okay, so when you're working on the project, which is the iteration 0 is due this week, right, this Friday, which I know some of you have been asking a lot about. Keep in mind, iteration 0, the point of it is not really assessment. The point of it is to get you, just basically to kickstart you, forming your groups. When we didn't used to have iteration 0, we found that people didn't really get started until later, and it was too late. So don't really stress about assessment for iteration 0. It's more about just kickstarting a bit of energy to get you into your groups. So hopefully that makes a bit of sense. And you're not really even writing any code, you're just stubbing out some functions. So how's everyone going with iteration 0? I know some people have submitted. Who's submitted? Yeah, a few people. Is anyone having issues that aren't really resolved? A couple people. So one thing I wanted to speak about quickly is that if you're having issues that aren't resolved, who's been to a help session yet or knows about them? So a few people have been. So we actually had to cut down the help session this week because there was no one going. So does everyone know about the help sessions? Do you want a recap? Who's never heard of them? Well, you should have heard of them from last term, like from 1511. But if you go to, where did WebCMS go? WebCMS, and you go to help sessions under the timetable. You can see when all of the help sessions are scheduled and where they're located. There's a Microsoft Teams channel for the online help sessions. And we have tutors just sitting here. We had 3 tutors with no students for 2 hours the other day. So if you're having issues with, for example, here's hopefully our savior, everyone. If you're having issues with stubbing out assignment iteration 0, please go to the help sessions and try and get some help. Okay, so let's try.
You got an adapter already?
I got straight HDMI.
Okay.
Yep.
Don't need this one.
Oh, you got it.
Goes in here.
Everyone, cross your fingers.
This gets plugged in.
Just need
Power.
power. Yep.
There is power, right?
Yeah. You never know.
And then, will we open here? Didn't even get recognized, did it? Your computer didn't even recognize
No, but
it.
let me.
Is it on? Yep.
No, I think it. Yeah, it did.
Oh, it did. Something happened.
HDMI laptop, both projectors.
I thought you were getting a green screen. What is that? Is that what was happening before?
Something similar. I think it's completely stuffed, to be honest.
Let's check out your display settings. Right.
Yeah.
Further down. Yeah. That's what do we got here? Optimize for new tag.
That looks like KG DCP there.
Come on, it should.
It's never been both broken. I reckon it's even something.
Is that just today?
Yeah.
They said they replaced the switcher in here.
We got it working last week. They replaced a box up there, and that was working for both. And then today announced.
Did you reboot this lectern when you got here?
No, I don't think so.
Sometimes that helps.
We can yeah, we can try that.
So what that does, it just reboots everything.
Yeah,
Right.
okay.
Unfortunately, it also takes some time.
Yeah, I know. Yeah, this.
That's locked. Still have the DVD player in here. Yeah,
Yep.
We tried
What's that one?
this HDMI.
No, I've not tried that.
Could be an option next, but it might be awkward to get to it.
You know what they suggested? It's to put my laptop underneath, upside down there.
Well, I thought the VGA.
I think this is AV.
Yep. I thought the VGA was.
No, they couldn't.
Yeah.
Not working.
So we just rebooted the system.
Any joy?
No,
It's still turning back on. Don't know.
no, it's not turning on yet. Now it is.
Do you know if there's a...
Is it showing that one?
Yeah, yeah.
It is. Right.
We'll just see what happens after this gets rebooted. We're trying to go through a box
To strip out.
that does a loop that hopefully avoids the HTTP issue,
Yeah.
but I'm not sure if it will.
No, you need to use VGA to avoid it.
That's what they say.
Yeah.
VGA is crap. Like,
But this was working last
really
week.
Max crap, not the VGA.
I don't know about that, but
yeah,
this was
Well,
working last
They put the
week.
protection on it, so
it's happening on the Dells as well.
well, that's our Dell.
No, on the Dells that were given to the academics, they have
right.
these touchscreen Dells. That's happening
Okay.
to those as well. So HDMI, both.
I'll try mine with a new cord because the cord may have been damaged.
Whoa. Yep. It's going through. I think.
That's
it's going
my
through
local
there,
screen.
yeah. All right.
I don't even know what that is. Is that not
Yeah,
live?
did-
Yeah,
did
it's
you
not
go-
live. That's all.
Okay.
That's me setting up.
All right.
Yeah, there's the streams, so we are live. Yeah.
No input. Sure, there's an input.
I've pinched it
Oh.
just to test because I have a feeling it may be something in the lectern.
Yep, that's what was happening.
So it's not the cord. It's not the cord, right?
Well, it's not this cord, but it could be the
No.
cord inside the lectern.
Yeah, exactly.
Jake, sorry about this.
It's okay.
Is there a lecture right after this as well?
Yeah,
So you can't even go overtime.
this happened. Yeah.
It's so much easier to just do a pre-recorded one, right?
Yeah.
But nobody wants that.
No, they wanted to.
Let's check the VGA.
I'm happy to do VGA today.
Let's see if this is putting out. You don't have an HDMI extender, so we could try this one. Yep, that's going through. VGA is working. Let's see if overhead projector is working. Which one's that one? Document camera. Yep, that's going through.
Can we try plugging that straight in?
Yeah, it just doesn't have a lot of. There's not a lot.
I can move this.
No, that doesn't do it. That's as far as it goes. There we go. And right. And you get a little speaker here.
That works. on one. Oh, that's okay. We can do this for today. I gotta start. Yep. Thank you for now.
It's going to
Yep.
get in your road if you fiddle
Yeah.
too much. Yeah. We'll try and get that
That's a li-
HDMI.
I gotta
fixed.
type on this though.
Yeah. Does it still reach? There you go.
Yeah.
Fine.
Okay. Does this move? No. Okay. Okay. Thank you so much for coming. I
No
really-
worries. This is the one that stays here. Alright. One way or another, we'll fix this.
Yeah. Right a few.
Sorry, it's just
That's-
an old
Yeah, I know. That's
crap
alright.
lectern. It needs to be replaced.
Yeah.
Hopefully can get that out.
That would be very good.
Just maybe if you can remember, put that HDMI back on there.
Yeah. That's fine.
No worries.
Okay. Thank you. Thank you. Thank you. Okay. Thank you, everyone. Okay, everyone applaud John Paul Basada from CSC for coming. Thank you. Yeah, this is how the university tests me. Okay. So can you see online? If you can see online and you can see in person. So I think that's what we want. Apologies about that. We're going to have to miss a bit of the second content, but it's actually nothing that's going to cause issues with the project or anything like that. So it's best that we get straight into the first part of the lecture because it's much more useful. All right. You can hear me online still? Please let me know. No one's saying anything? Hello? Yep, okay. Okay. All right. So, dynamic verification, the real the real start of the lecture is now 30 minutes. We can make this work. So who's heard of test-driven development? The term? Maybe you've not done it. Maybe you've done it. The idea of test-driven development is that before you actually write any code in your project, you think about and you write the tests for what it is that you're trying to build. It's one of these ideas that is very heavily discussed in software engineering and not often actually adhered to, but it's very valuable if you think about the idea. So let's take a step back from test-driven development and just talk about tests. So who's written a unit test or an auto test before? Anyone? A couple of you? Awesome. Who's heard of it, but thinks they know what it is, but's never written one? A couple of people. And who's got no idea, really? Okay. So what a test is code written in a specific way that is just used to test your application logic or your code itself. Heavily testing large systems is extremely important for writing robust code and protecting against regressions. We'll talk all about that in a moment. They prevent bugs, they prevent crashes, they're really useful. There's a couple of different approaches to testing. In this course, for the project, for your assessment, we're talking about black box testing. Very, very useful. So that's what we're talking about today. So what is verification? Verification in a system is making sure that the characteristics of the system are what we want them to be. So it's making sure that the requirements of our specification, right? So if you think about the project, we give you a very detailed specification. It's making sure that your code adheres to that specification. It's actually quite simple, and we're verifying that. So we're just checking that the system is built correctly. It's very simple. Poor software quality costs more than $500 billion per year. Absolutely, don't doubt that for a second. If you think about you're building a product, something like YouTube, you've got maybe 2 weeks for a sprint, we'll talk about sprints later, and a bug comes up that's quite critical, what's your team going to be doing? Fixing the bug, I hope so, right? What does that mean you can't do? build something else that's actually going to generate value. So that loses value because you could have been building some subscription service, right, to make money. Instead, you're fixing a bug because someone picked integer 32 for the view count of YouTube videos, for example, right? So that you can imagine that it adds up. Then think about bugs that are so bad, it takes months to fix, right? Then you're backlogged. Then your competitors are beating you. It's a big problem. There's two types of verification, static and dynamic. You will use both approaches in this course, and both approaches are absolutely useful together. It's not a matter that one's better than the other. So who has an idea what static verification means? Someone online says make the bug into a feature. Yeah, good idea. So static verification, anyone? Or what does it mean if we're doing static analysis? Has anyone heard this term? No? Okay, static analysis or static verification is when you're testing something in your code without running it. You're not executing the code. Who has used, in 1511, the, like a code formatter? Has anyone used a code formatter? Where you hit, in VS Code you go Control something F and it formats your code, something like that. No? What did you mean? You've manually formatted it? Well, I guess that is a form of static analysis. You're manually going through the code, but you're not executing the program, right? So if you've used Visual Studio Code, sometimes you click a few buttons and it puts your code on different lines and stuff. That's static analysis. It's literally looking at the symbols in the text file and going, oh, there's a curly brace here and a curly brace here. That means that's a group, right? And I should indent it, for example. That's static analysis. Dynamic verification is actually executing the code. It runs the program, puts some values into it, and says, okay, if I have a function called add, and it accepts two numbers, and I actually give it the number 1 and the number 2, what do I expect to get out of it? The number 3. And actually running it, that's dynamic verification. Both useful together. So the purpose of doing this as well, especially static analysis is very useful for this, is for software safety and security. So safety is protecting from accidental misuse. So a user enters a value you don't expect into an input box and then your app crashes because you got something instead of what you expected. Security is protecting against malicious actors. If we're software engineering big systems, we're going to run into both of these. So we need tools to help us avoid common pitfalls that we often run into. This reminds me of a little anecdote, not that we really have time, but anecdotes are fun. I was at a conference, software engineering conference, and Google were presenting on some of their efforts in static analysis. So something interesting about Google, did I say this last week, but every single code repository at Google is in a single repository. Did I say this? No, I said it to someone else. It's called the mono repo. So if you got 1531, you got your Git repos for your labs and for the project, and they're all different repos, right? What Google do is every single Google project is in one repo. It doesn't seem to make sense. It's the largest repository on the planet. And the reason they do it, right? Does anyone know? Or online? Anyone guess? Why does Google do that? It seems really silly. Pretty much. It's so you can apply static analysis tools to every single line of code that's written at Google. Whereas if they were all scattered on different repos, you would have to build a lot more. You'd have to sort of track where every single repo is, how do you get access to all of that. It's a pretty shocking fact. But they build a lot of tools to help manage it. And that's so that they can look for problems that they've learnt over time protects them from accidental and deliberate misuse. An example, a very simple example, might just be looking for an uninitialized integer in a C program. It's actually fairly simple without even running a program to see, did I do int x and never assign it something? So they will just go through and look. So if we're talking about memory safety, it's really useful to compare C and JavaScript. So JavaScript prevents access to memory that hasn't been initialized or allocated, and it does this dynamically at runtime. C has no mechanism like this. If you create a pointer to a piece of memory and you never put anything there, you can do that, and your program will probably not do what you expect it to do. And as a result, can open you up to vulnerabilities, where someone can access memory that they shouldn't be accessing. Yeah, you can dereference pointers even if they're not pointing to anything that you allocated in your program. The reason for this is C is prioritizing performance over safety. Sometimes we want to do hacky things in C for performance gains. Ooh. What's wrong? Oh. Yep. In JavaScript? Yeah, exactly. They do something like that. Exactly right. There'll be a default value for, in fact, it's probably null, but it's like not a real null, if that makes sense. But you can test that. You can test that. Okay. So let's talk about static verification. It's considered robust and reliable, but it's limited. Not everything can be statically verified. Although it's actually very surprising how much can be. We're going to use two forms of static analysis in this course in the form of JavaScript ecosystem tools. One called static typing, which is in the form of TypeScript, which is a static system. So TypeScript is one of my favorite languages. It made me fall in love with JavaScript again. So basically, JavaScript, as we know, has no types, but everyone's using JavaScript. So Microsoft came along and said, what if we made a variant of JavaScript that added types, and they did it all statically? So nothing actually changes in the JavaScript runtime. Very interesting stuff. And linting. Linting's also very, very useful. But today we're going to talk about dynamic verification, or basically testing. It's the process of dynamic verification occurs when you actually run the program. You're actually executing the code that you write. Testing in the small and testing in the large. There's a caveat here. Even the most thoroughly tested system is still going to have bugs, but it probably will have less issues, right? We will not, as humans, think in advance of all the edge cases that will trigger an issue with our software, but we can protect against common issues. So it shows the presence of bugs, not the absence of bugs. It's a very good quote there. Yeah, some systems break, unexpected data is flowing through our system, invalid input are all things that can happen. But if we can protect against those occurrences, we've got a robust system. I think jumping into a demo is probably the best way to demonstrate this, which is sort of in the name, isn't it? Does that sound good? So let me run through the slides a little bit, and then we're just going to turn this into a demo, and I think that's going to be the best way to demonstrate what's going on. So here's a JavaScript function, getEven. So you give it an array of numbers, and if the number is even, you add it to a new list, which you return at the end. Okay, so this means if I give this function 1, 2, 3, and 4, what will be returned? 2 and 4, pretty simply. Now, pretty simple function. Do we need to test something like this? What? Who said what? I cannot see where. Put your hand up. Oh, there, yep. Negative, yeah, that's right. Negative. Did you think about negative numbers? Who thought about negative numbers? Okay, who thought about if I gave it no values in the array? Someone thought about that. Who thought if I gave it an array of an object? Who thought about if I didn't give it an array at all? Because this is JavaScript, there's no types. I can pass this a character. Who thought, what if I gave this a string, which is sort of an array, but isn't really an array, right? So even in this very small example, there's a whole bunch of, now, here's why maybe this is the most relevant, see that'll perk everyone's ears up. When you go to apply for your tech jobs at Google, Atlassian, or wherever it is that you want to apply, and you do your programming tests, they will say write some code, and how do they test it? They have pre-written a bunch of auto tests that do exactly what I'm describing. So if they say write this getEven function, they will then run it with a negative array, an array with no elements. They'll pass in null. I'll give you another quick example. I was doing, this was actually like a fever dream. One night I was working on my PhD, I was writing some Python code, and I was, you know when it's like 2 a.m., you've got 500 tabs open, you're like, don't know if you're a genius or like manic, you know the feeling. And I'm in that, but I'm making progress, and I Google like another Python question, and the Google homepage, like literally in 3D, fell back, and it became like a Google hiring thing. And they were like, they've got some system that's like looking for, if I was doing AI stuff, and I guess they want to hire AI people, and then it became like hiring tests. And if you pass them, you get through like to the 3rd round. Anyway, it was this weird, I thought I was having like a moment or whatever. It was, yeah, I mentioned this in the other time I was teaching. But when you do those questions, I remember one thing was to write a function that, given some data, builds a balanced binary tree of the data. I don't know if you've done binary trees yet. That's maybe a data structures thing, which some of you were in just before, right, with Sushmita. So there you go. And you got to think of all the edge cases. What if they give you no data? What if they give you this and only negative numbers? And they're just testing that you're building out the tree right. And one thing they do, which is really, really clever, and the most common way to do this, by the way, is with a recursive function. So you know, if you've done any data structures before, you have a function that calls itself and builds out the tree. It's the most common way that it's taught as well. But what they do is they give, in one of the tests, they give it so many pieces of input that it breaks the recursion stack on their system. And so you would just fail the tests if you did it recursively. If you build it in a different approach, it passes. It's really hard to think of that edge case. But if you have really good auto tests, it's going to catch it. So how do we actually write code to test this then? So one thing that we could very simply do is just log out some test cases. 1, 2, 3 should return 2. 4, 5, 6 should return 4 and 6. 7 should return nothing. But I would have to manually check, right, that the output is what it should be. I would have to go through every time that I change the function and check that it's giving me the right result. Yeah, let's not worry. So the question was, can't we just change the solution itself, right, to use .filter? Yeah, sure, but you still might need to test that. Yeah, the point of this, though, isn't what the function does, because this is a simple example. Agreed, but the point is that this could be this could be get even if the day is Sunday. Then you've got to write more code. So if we have a more complex function, right, which we will in a moment, you'll see that, yeah, sure. You don't have to test JavaScript itself, you're testing your logic. Okay, so we can make it a little bit better, so we can actually check, if I call getEven, passing in that data, does it equal to what I expect? If it doesn't, put something into the log. This is a little better, because now I just have to check for the presence of output. Does that make sense? Because if this spits something out in the terminal, that's a problem. Still really not great, because I've got to manually go through and check. So this is not testing. This is more similar to debugging. This is what you do when you're writing code, right? We all agree. You do heaps of console logs, heaps of printfs when you're writing code, especially if you're stuck. It's one of the most useful debugging techniques. Testing is a little more automated, a little more structured, and there's tools to do it. Now, I want to just briefly introduce this idea of black box testing. your question was very good. Where did it go? Black box testing is the idea that as a test writer, I don't want any clue on what's happening in the function. I do not want to know what the function does. It's none of my business. Do I need to know how this function gets evens? No. Someone else in another team can be writing it. It's not my business. But what do I know? I know what it should do. I know it should return back the even elements. So black box testing means that none of the code that I write to test it does anything to the internals of the function. I don't check what's in this evens array. I don't even know that there's an evens array there. This is very valuable because it means someone in your project can be writing code while you can be writing tests, and you can finish your tests before they've written their functions. The other reason it's useful is because if you're white box testing and you're testing the internals, your tests become very tightly coupled to the solution. So if one day someone comes in and rewrites a function that does the same thing, your tests will all break. Does that sort of make sense? In this course, we only want to see black box testing. There's another pragmatic reason why this is very important in this course. The reason is you're going to write lots of code for the projects. We already have auto tests written. Every one of you will use a different solution, so we can't test the solution, but we can test that you're doing the right thing. So in the demo, we're going to be testing this function called remove vowels. So we're going to have this function that takes a string. If it finds a vowel in the string, removes it, returns a new string with no vowels in it, consonants only. Now, to start off this demo, you can see here that remove vowels is not even completed or started. Do I need it to be completed to write my tests? No, because I know what the function should do. Now, these are very simple examples, and we can infer from the name of the function what it should do. If it's a more complicated example, that's why you have a specification. So the specification we give you for the project is a pretty good example of this is what should happen, this is what should happen, this should not happen, it should return this, if this, return that, right? That's a spec. This is a very simple reduced example. All right, so remove vowels. So let's go to our code base here. And in the week 2 code repository, I've made a folder called testing, right? And so actually what I'm going to do is open this in a VS Code window. All right. Now you can see there's a bunch of files there. I already sort of went out and created this project. Let me point out the important ones. So we have vowels.js. Now this is just the code file that's going to contain the remove vowels function and exports it. There's really nothing interesting here. Do we all agree? And you can see that I've not implemented the function itself, but I've stubbed it out. So the function exists. It's removed. Okay. Now we have this package.json. Remember, so this would be a really good if you're at your laptop to follow along as we go. It's really good to get hands-on with this. Remember, if you do npm init, we need to add this type module to the package file because we're going to be using importing and exporting. Now you can see that there's two what's called dev dependencies here. One called Jest and one called preset. So you might be thinking, what the hell is going on with this? So Jest is a JavaScript node package. Remember we spoke about npm yesterday? Jest is one that does JavaScript testing, Jest. That's where the name sort of comes from. It's a very popular framework for writing unit tests in JavaScript. And it's got some syntax that we're looking at here that describes how to write a test. So in this case, we have a test called users. The test is called users. And then we call this special test function, which is provided to us by Jest, and we have this function called expect. And what I'm saying is expect something to equal something. So there's a little bit of boilerplate going on here, and we don't really, the goal of this sort of lecture at this point in time is not to really explain exactly the mechanisms of JavaScript being used here. There's some sort of hooking up and stuff going on. But this is, you basically, what you sort of do is copy and paste a block like this and replace the two values with what you expect versus what you get from your function. So let's do an example. So we have this remove vowels code that I just showed you in the code base, and now we need to install Jest into our package, right? Something different from yesterday. Do you see this has --save -dev? Does anyone know what this means? Maybe, no? JavaScript projects have two types of dependencies: normal dependencies and dependencies only used at development stage. So here's a very simple way of explaining it. Is your user going to run auto tests? I hope not. No, they shouldn't. They should be using your product. So we only want to ship this software, this code, when someone's in the development phase. And so doing save dev tells npm to do exactly that. So we just run this command. Let me open a terminal. In the project directory that we have our project. I've already installed it, so it would just add it here. Okay? Now, when we give you the lab repos, we will set up when we do Jest testing, there's a few files and configurations required that are just mandatory and they're not really valuable in explaining. So when we give you the labs and the project, I think the project, we actually already set up a few things like this. You do need to also install this dependency here. And so that's the line for that. npm install --save dev @babel/preset-env. So those are the two things you need to install. Dependencies are the libraries of JavaScript code that you're downloading that someone else has written that you're using. So this is something that's sort of doesn't exist in C. Yeah, these are completed projects that you're downloading and using, and npm is a tool that helps you find, download, install, and use these packages. And to do the testing, we need these two packages installed, so you can just install them. Yeah. What you could do is literally download a .js file, copy it into your project, link it, but npm does all of this for you because you use a lot typically in web applications. Exactly. All right. Now, you do also need a couple of files that we will give you in any of the repositories. So maybe a good way of doing this is downloading this project once I publish the code and then playing alongside it. Or if you Google it and find these files, or if you even look in one of the labs, I don't know if they've rolled out yet, they're in there. But you just need a few config files. It's a little unfortunate that they're required to get it working, but they are. Okay. Okay, so we have our JavaScript file called Vowels, and we also can now make a test file. So vowels.test. So here's one I've prepared earlier, and it's basically just describing a bunch of tests that try and test the edge cases of our vowels code. Now to make it simple, just look at one together to look at the composition of it. So what's the name of this test? Yeah, remove, no. What's the name of this test? Deal with no vowels. That's the name of the test. So this is like, I'm registering a function, a test function called deals with no vowels, exactly. And it does two things. It calls my remove vowels function, okay, passing in BCD. Remove vowels is just imported from here and it currently just returns false. So it calls the function I wrote, saves the result, and then it does this thing. I expect the result of my code that I wrote to equal BCD, because if you remove vowels from BCD, you should get BCD, because there's no vowels in it. Make sense? This syntax you just have to remember. I expect something to equal what I expect. And that's it. That is a full test. Then you can go on and just write lots of other tests. I want to test if you've got, that's the same test. I want to test with if you only have vowels, if you start with a vowel, if you end with a vowel. And this is what testing is. Testing is often kind of boring. It is just like very repetitive. You're testing the edge cases, you're testing, all the different things that you come up against. Is there any questions with this syntax here? Yep. The shortcut is you copy and paste the test and then you fill out the, like if I'm writing unit tests, I duplicate a previous test and change the past in and the expected.
So essentially there's no shortcut.
Not really. There might be some extension you can install.
The expected output is multiple lines, so like quite large. Like you're expecting to equal like some.
So this is not testing exact output. It's testing actual JavaScript objects. So as long as the objects have the same keys and the same values or whatever it is, it's going to find that they're the same thing. It's handling how to do that internally. If I give it the string hello and there's a new line character after the first L, if that's exactly what's in the other string, that's fine. I think the reason you might actually be asking that, I'm taking a guess, is because in 1511, we test terminal output. Is that why? This is not testing terminal output. It's testing the actual value in the variable. You do multiple expects. Yeah, so you would just make another test that sets up your project with the different mode.
Is like this test a function taking two parameters, like dealing with no vowels is the first one, and function returns whatever that is not.
Yeah, I don't really want to go into the mechanism here, but I'll briefly explain it. Test is a function in Jest that accepts two parameters, a name and a callback, right? That's what this is. This callback is a function that returns, that contains some expects. But we're not at the stage in the JavaScript content to explain what's going on there. Okay, yeah, again, we're sort of intentionally omitting it. The arrow symbol says that this is a function that does this. It's just JavaScript syntax. Okay. I have a special font on my computer. It's an equal sign and then a forward caret. Was that a question there? Or it was answered. It was answered, yeah. Yeah, I always forget to turn it off and it confuses people. So yeah, this is called font ligatures. Yeah. Okay. this is something sort of interesting. Once we start dealing with more abstract languages, there's often more boilerplate, code boilerplate. This is a good example of code boilerplate. What's interesting to me in this code is basically this expect and maybe this line, right? But all of this is what we call boilerplate. It just needs to be there. It's not interesting. It's just part of the mechanisms that describe what we want to do. All right, so let's remove this test because we've already got it tested. And so what I've done is written a bunch of tests here that test different edge cases. Now I can actually run the tests. Now how do I run the tests? I can't just run this JavaScript file. That's not how we run tests. We actually use the Jest program. Now, the Jest program is actually downloaded for us into Node modules. There's a shortcut so we don't have to do this, but we'll introduce it later. For now, this is what we're going to do. So I'm going to say, in my terminal, in the Node modules directory, there's a .bin directory that contains an executable called Jest. And this is the program that I want to run. So just think of it as instead of running Node, we're running Jest. And then I give it the file that contains the code we want to test. So I can do that, and I'm testing this vowels.test file. Make sense? And it's running some tests, and it's failing them, which totally makes sense because vowels.js returns false. So I would hope that these all fail. And if we scroll through these, you know, that's an unfortunate test case there. But it's saying, you know, I expected to get, let's pick another one. I expected to get the output B, right? Because the test case was BEE. But what did I really get? Because the function always returns false. And you can see every test is failing. It's pretty cool. Yeah, someone online has said you don't actually need to give it... Okay, this is something that'll trip you up. It's tripped me up before. You need to have .test in the file name of your test JavaScript files. That's what Jest actually looks for when it's running the tests. So if you called this 2.3 blackbox.js, it actually wouldn't run the tests. When I was building this lecture project earlier, I forgot to put Jest test in the file name, and it was not running them, and I was like, what's going on? So you've got to have .test in the file name. And so that means you can actually just give it Jest in the current directory, and it's going to look in the current directory for any JavaScript file that's got test in it. Okay? So it's running through, and this is why it's dynamic. It's actually running our code. Do we see that? It's running the function and it's returning false. That's why it's dynamic.
So is this more an example of white box testing or black box testing? Because you're not doing anything quite complex and now...
Doesn't matter what we give the function and what we get out. This is a black box test. The reason that this is a black box test is if we look at our tests themselves, we test the input. So we call the function with some input. Sorry, here. We call the function with some input, and we test the output. We don't test, is there an array in there? Right, we don't know what's in there. In fact, there's nothing in there. That's what makes it black box. If I was to do something like, you know, did the function print something to the log? That would be white box because we're getting into the internals of it. You can literally picture it as this. It's like going to a restaurant. Right, a restaurant is an example of a black box transaction. You ask for food, you give her money, and you get the food. You've got no idea what's going on back there. Is there a hand here somewhere?
You have to specify what file you want to test.
If you just run the Jest program, it will test any JavaScript file in the repository.
Do you have to specify what this test is
Yeah, that's the name. And all that,
No, like for what file? For what file? Not for what purpose, but for what file?
it's whatever the test, it's whatever function the test calls. In this case, it's calling remove vowels from the vowels.js file. Someone was asking, what's the command to run Jest? It's just here. But there's a caveat here. You do not need to be typing this into your terminal every time. We will show you how to make that a bit nicer in a moment. Okay, is any conceptual, is everyone getting the idea of what's going on? Yeah, yeah. Okay, white box testing is like you going to McDonald's and counting how long they put the fries in the fry vat. Black box testing is like saying, is my fry crispy? Yeah. You're just testing the product. Pretty good analogy, huh? There was a hand somewhere in the middle? No? We're okay? We're okay. So here's that's the larger test file. Now, remember yesterday, who was paying attention? I said we can register scripts in our npm package.json file. So why don't we register the Jest command? So to do that, we open the package. Let me open up, that's annoying. Let me, so I think it's called, it's called scripts here. So scripts, and then the script, I can say I want a test script, which does in the node modules in .bin run Jest. I think that's all fine. So that means I can do npm run test, I believe. And do you see that? It ran that command and failed the tests. So now you don't need to remember what that command was. You can just run npm run test, whatever you name that command. So that's a nice little shortcut. Yeah, this is exactly like PyTest for Python. Yeah, exactly. All right. Something else I want to mention. Describe. So when we have a describe in our tests, okay, let's look at something here. Describe has multiple tests in it. Do we all see that? Yep. Describe is like a grouping. It's like this is the set of tests for removing vowels. Because you could have a function like remove consonants, which will have a different describe. So that's like a top level group. But the key here is that you can do multiple tests within a describe. The question is, do you test every function you write? Is that right?
No, let's say in this provision removal, so we only describe it once, right? And then we write test next.
Yep.
Let's say there's multiple functions. For each function, you have to describe it.
The way you break the grouping up is sort of up to you. If this could be, imagine this was a very, very critical function that's very important in my system. I might want to have multiple describes about it. It depends how tightly you want to test the thing. Yes. Yeah, and the output would group it under the describe as well. It's just a grouping mechanism to help you narrow down where the test failed. All right. In the project, you will be writing lots of tests. Okay? Here's an example for test that if the user registers for your backend and you give an invalid email, should you be authenticated? you would hope not, for example. So you will be writing a lot of tests in this format for the project in the future. And this is the caveat I was talking about before. Jest relies on some ideas around the function syntax and callbacks that we're not talking about yet. That's okay. And there's a few things you need to set up for COMP1531, and we will do that for you in the starter repositories that we provide you, because it's not very interesting to do every time. Now, another important note, from week 3 onwards, all the labs, or most of the labs, will have auto tests, Jest auto tests, which means we will, when you push code to the repository, we will run our auto tests to make sure automatically that the code you write is what we want. Okay, let's actually implement this function and then test that everything passes. Does that sound good? And see what that looks like. Okay, does anyone know how to do this? If anyone's brave, you can read out some, I'll type in what you want to, or you can actually, I forget we're in person. Someone want to come up and type a solution? Come on, there's got to be someone that's written JavaScript many, many times. You in the blue shirt? Your friend was nominating you. Do you know? Do you have an, you can, it doesn't have to work. We can try it. Come on. Someone come up. Come on. Yeah, that's nice. That's nice. All right. So you can just write, and there's no, well, I was going to say there's no right or wrong, but there is. That's what we're testing for. But you don't have to get it right. Let's just come up with an idea.
Maybe like 4.
Oh, interesting. Oh, I like this. I think the stream's lagging. That's not good.
Yeah,
we can see where this is going. All right, hopefully the stream's back. We want to see blue shirt code. That's what they said. Oh my god, this is... this poor camera.
It's gonna take a while.
It's gonna take a while. All right, that's all right. Now what are we gonna do? So if we come across a vowel in our string, there's another one. Oh my god. Why don't you just do it for the lowercase?
Yeah, sure.
Just do it for the lowercase.
Cool.
How does that? Oh, it's okay. I don't think we'll break the code later.
Yeah. Splice?
Oh, this is I got to be. I don't think the splice will work here because you're looping through the array while you're splicing it. I don't know if it'll work. What I would do here is make a new array or a new string and add the characters that fail this condition.
Yep.
So we go. Yeah, we could do yes, sure equals. Yep. Okay, sure.
Yeah.
And then we go. Yep, string plus equals. To now this is if we want to do this if it fails, so put an exclamation mark there before the bracket though,
Before the bracket.
because we want to, if they are all not true.
Does that work?
Why doesn't that like that though? Let me see quickly. Oh, okay, I might want to something like that. There we go.
Okay.
All right, that was pretty good. I think the base idea there is good. Yeah, that's a good solution. All right, let's gonna see what happens. Oh, you passed one test. That's not bad. So let's see here. This is the output. So what's going on there? Oh, you put the string letter. But do you see how, honestly though, the test helped us figure that bug out. No one caught that bug. No one said like, oh, look at that. That's pretty good. Now, I think I mean, if we were to do something like, add a new test, like, Jake wants to get blue shirt, and then we say something like, that should probably, I mean, this is where, like, I don't actually know what that should equal. Should that equal that, or should it equal, I guess that's right. Right? Now, I know I did stop you from doing the capitals. You were going to do it, but I can improve my test suite and find edge cases that we missed when we implemented the function. So this is where actually something to note here. Insufficient test suites give you false confidence. Did you say so true? Is that what you said? I agree. I'll say it again because it's really useful. Insufficient test suites give us false confidence. We get a serotonin hit when we see the green all tests pass, but if we're missing tests, like, we're still screwed. So don't get the false confidence from passing all your tests. You've probably missed something. Now, what's really common, you come across a bug in deployment, right, in production, you go, oh my God, I did not think that a user would do that. I did not ever think this was possible. You fix the bug, and then what should you do? Sorry? Before you test it again? Not look for more bugs? Add a test that tests what you missed. So that if in the future you fall back into that position, the test will fail. All right. I actually prepared earlier my own solution to it, and you guys tell me what you think. This isn't to besmirch. I don't know why I'm calling you blue shirt, but it seems to work for me. But this is what I wrote this morning. Okay. I think that should pass. It probably doesn't pass the uppercase auto test, but it should pass. Whoops. Yeah, it passes all but the uppercase auto tests. We can fix that by doing is it too lower? Someone say yes? Actually, not there. Or is it string.lowerx? Does anyone remember? Anyway, you just make the string lowercase, and if that passes, keep the string. So this is another approach of solving it. What I'm doing here is you take the string. Does anyone know what this syntax does in JavaScript? It's pretty cool. So it takes something like a string and unpacks it into an actual array. So now it becomes an array because it's not an array, it's a string. For of lets you iterate over a string like it's an array. This turns it actually into an array. And then I'm going through each element, I'm filtering each element in the array, and I'm only returning it if it's not included in the vowels list. So I don't have to create a new array in this. So it's using less memory, it's using less lines of code, but you could, and then actually what I'm doing back here is turning it back into a string. That's what the join with an empty string does. Yeah, it's the spread syntax, yeah. And so you can get a nice two-liner. In fact, actually, we can get it even down to one line if we just do that. Yeah, same thing. So there we go. There's the nice Renzella one-liner. It's not that exciting, but cool. All right, and then if I, fix this to deal with the uppercases, or another quick way of really doing it is just, if you were to add the rest of the characters to the... Oh, it still fails. What's wrong? Oh, I really sabotaged you. Yeah. Yeah, exactly. Good catch, yeah. And then there you go. That's how we help write better test cases. Okay, cool. All right. Do we want a quick 3-minute break? Is there any questions? Are we excited by this concept? Any project you work on in industry that's worth its salt is going to have some auto test framework like this. It could be NUnit in C#, PyTest in Python. There's other ones in JavaScript. There's equivalents in every major language. They're very, very useful. Maybe at the end of the lecture, if there's time, I can show you all the auto tests for a production system that I work on. There's, like 50 plus files, hundreds and thousands of tests in some cases. Someone on the live stream posted you can do a regex replacement actually that's very, very, even less code than this. Someone said they're lost. I think that's okay. If you've got specific questions, ask it. But the best way to get your head around this sort of stuff is just to write the code yourself. Follow along the lecture video and write the code. Another caveat, you're not meant to understand this. I was just showing off. The previous solution was very good too. Okay, 3-minute break everyone, and then we'll come back and talk about working in teams. You can come up and ask me any questions if you like. Okay. Okay, another, can you? All right, hello? Is that working? Oh, it's sort of working. Can you hear me at the back still? Yes? No? Can you hear me? Yes? Yes, okay. All right, I just want to make a quick caveat with all of this stuff for the project. Sometimes you get given constraints or a contract. So here's what I'm saying. If we tell you, for example, in a lab or in the project specification, this function will always only ever be passed, for example, a non-null value. What that means is we do not need you to write the test that tests that it's not null. So we're not going to adversarially trick you with the auto tests, is what I'm saying here. So if I say, another way of putting this, if I say, for example, this function should always return a string, you should make sure that that function adheres to that contract or that specification. What we're saying is, when we give you a specification, you've got to test that you adhere to that specification. But if we tell you, you will never be passed in X, Y, Z, we're not going to do that in our auto test. Does that make sense? Pretty simple sort of fact there. All right, and that is the dynamic verification lecture for today. So please, lecture feedback, I'll leave it up there for a few seconds if anyone wants to scan the QR code. I can hear the music. It's anonymous, yes. Yeah, it is, yeah, it is. I think there's an optional spot to leave your ZID. Sometimes people leave anonymous feedback and it's like, I desperately wish I could just explain that they missed the link or something. Anyway, it doesn't matter. All right. Everyone scanned it? Yes, 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 yes. You can go watch the video online. In fact, it's the same link every time, so you can bookmark the form. It's the same link every week. All right. So this is the teamwork. Oh, I've got something else to say soon. Don't let me forget. Someone remind me not to forget the thing I'm wanting to not forget. All right, so teamwork. So by far, if you look at Reddit, Discord, the number one thing people complain about 1531 is teamwork and the group work. If I was purely motivated to get the best my experience score, so it's interesting. My experience when you do the surveys at the end of a course, 1531, my 1531 results are always about 3% lower than when I teach 1511. And I'm pretty sure it's due to the teamwork, although they're both quite good, typically. We'll see. If I can't fix these lecture issues, maybe they'll go down. It's clear that group stuff causes. I know I was a student. I've had great groups. I've had really annoying people in my groups that don't do anything. Some people that are like really type A and they're like, what do you do? Like 24/7 check. I get it. However, this is the software engineering industry. You will always work in a team. These little moments that you have you will be exposed to them at some point. I know it's a bit of a cop-out to say, well, just get over it. But to be honest, if you want to build big systems, you need to work in teams. There's just no way around it. And there's no better way to explain all the nuances than to get people to do it. So that's the first thing. But there's a number of activities and tools that goes on in modern software engineering that helps us work in teams and be very productive. So who's heard of the word agile? It's absolutely everywhere. At some point, I remember when agile was getting really big, there were agile consultants that used to go to tech companies and consult with them on how to be agile. So people were making lots of money for, I don't know what they were doing. But it's a hot topic. What does it have to do with computing? The word is so abused. It's so misused. It's associated with things like sprints, scrum masters, iterative development, blah, blah, blah. If you follow it, you're guaranteed success. We're not too interested in it. In fact, in every software team I've worked in has been agile, and they've all looked different. So agile isn't one real thing. It's a set of philosophies and principles that actually I think are very, very important and very useful. So this is the actual original homepage for the Agile Manifesto. And there's a set of core philosophies that the people that originally came up with this idea describe. So it's individuals and interactions over processes and tools. So don't strictly adhere to what's written, do what's best for the product and for your users. Working software over comprehensive documentation. I remember, if you go back to the 90s and 80s and 70s, systems used to be much more richly documented. There used to be a lot more people where their dedicated job was to produce very comprehensive sets of documentation. Now, it's very rare to find very well documented systems because the industry has moved towards that we value better systems themselves than better documented systems. There's cases where this has caused lots of problems. It's not always a great thing, and like anything, a good idea comes along and some people take it too far. Customer collaboration over contract negotiation. Work with your users and figure out what they want, what's best for you to build for them, and do that more often. Don't talk with them once and then 3 months later you deliver something and they've gone, I never wanted that, and you've wasted 3 months. And respond to change. That's why you've got to check in with them often, right? Whoops. But again, these are these philosophies, but what does it really look like in practice? Classically, if you took software or IT in high school, you've spoken about the waterfall software development model. Does it ring a bell to anyone? Maybe now it's actually starting to get kicked out of HSC curriculum, which is a good thing. Back in the day, software projects followed what we call the waterfall model. You sit down with your clients or your users, you come up with a very detailed set of requirements and what you need built. Someone's got some cereal, that's good. You then design what the solution should be, you implement it, you test it, and you deploy it, and that whole process can take weeks or months, or even half a year or something like that. But it makes a very big assumption that the thing that you clarified at the beginning is exactly true. It also means if you made a mistake at the requirement stage, you're screwed 6 months later, and you never checked in with your users. Agile, the way I would best describe it, is about turning that linear process into a loop and going through the loop every 2 weeks or so. That's pretty much it. It's really that simple. Build smaller deployments or build smaller products more often, rather than spending a lot of time building one big thing. Because most often, most of the things in that big result weren't the best use of your time. So we have these things, we call these processes sprints. So a sprint is where your team works on your various allocation of functions or functionality, and then at the end of, usually they're about a week or 2 weeks, and at the end of that week or 2 weeks, you get together, you merge all your features that you worked on in that sprint, and you deliver it to the customer. Someone said, I spent a whole semester on this at UTS, still no idea what Agile is. Well, we're gonna change that today. But that's literally what it is. I mean, that's it. That's it. So instead of meeting with the customer and describing what they want and going to take 6 months to build it, you build really small things more often. Time is fixed. Always the sprint ends at the 2 weeks. With the waterfall, what used to happen is you say, oh, I need another 2 weeks, senior project lead, I've not finished this thing. And they say, all right, well, we'll go back to the client, they won't be happy, mate, like blah, blah, blah. With Agile, you say, okay, then we're not including it in this sprint. Fix it for next sprint. You always deliver at the end of the sprint. only plan for the next sprint. So don't think, in 6 months we've got to refactor this code base. It's going to plan for the shorter term. This, again, it's a balance. You still need to plan for the longer term at some point, but in the day-to-day interactions, we should be thinking about what our next deliverables are. And what we want, typically, is to have a release at the end of each sprint, and a release being that we actually ship our product to the users. So this is a big departure of how it used to work. It used to be that think about Windows operating system. In that, you guys are getting young now, and I'm getting Windows 90. Anyone use Windows 98? Yeah, cool. So did I. 95? Anyone? Yeah, cool. Some people. That's good. But think of Windows 95. Maybe they started doing updates over the internet. I actually don't know. But really, you wait until the next version of Windows comes out 3 years later, and that's when you get a whole bunch of updates to Windows. Now, Windows is updating every night, right? Causing lots of problems. But really, that is the difference. That was waterfall. This is agile. Microsoft is sprinkling out updates to Windows, multiple times a week. Started using from NT. NT was always a weird one. Why was it called NT? So someone says, why are they updating so often? They're updating so often because they're working on smaller features more often. They're following more agile development practices. Now, I don't know the number, I'm making this up, which is not very academic of me. Most software projects in industry are agile now. Definitely at Google, at Atlassian, they're all like this. I'm not saying that you should never, there are some edge cases where a classical waterfall model development is optimal. An example might be where you've got a very rigorous specification that you know is going to hold true. So an example that I'm thinking off the top of my head is, imagine you're at NASA and you need to develop some code that handles some piece of hardware, and that piece of hardware has been ordered in, and the specification is extremely rigorous. Like, if it doesn't meet that specification, it's going back to the vendor. And your job is to write the firmware for it. You don't need to check in every 2 weeks with the vendor to see, because you've told them, this is what I want, this is what I expect, and I'm already getting started. So there are still some cases where you might take a longer linear development process. But for 1531, and for most of you, pretty much all of you, you won't be doing that. You'll be engaging in something that looks like this. And every company is going to have different terms and different little fun things, and they go, oh, we don't do sprints, we do marathon, whatever. But it's all the same idea. So stand-ups, you've probably heard of this. Stand-ups are the things that you do every single day. I remember during lockdown, our stand-ups were at 9:30 on a Zoom call, and I used to like my alarm would go off at 8:30, I'd ignore it, I'd snooze it, and then it would be 9:15, I'd be like, oh. And then sometimes, after a year, I'd be in bed, I'd be like, yeah, doing my stand-up. The reason it's called a stand-up is that when you're in the office, you literally stand up so that you don't take an hour to have this meeting. And all it is a meeting where you go around in a circle and you say what I did yesterday, what I'm doing today, and then if I'm blocked on anything. That's the core structure of a stand-up. And you just do that. And you don't sit down. Literally, you don't sit down so that you don't go, oh, and my coffee machine was broken, which is probably what my lectures sound like anyway. That's a stand-up. You do them every day. And you might have a bigger weekly meeting. Yeah, maybe you don't actually do that, but that's the idea behind it. They used to be just, I was in bed, so they were lay downs at some point. Oh, God. That was an awful project. So you track the activities that everyone's working on. You use something like a task board. The most popular one is Jira, right, which a lot of you will potentially go and even work on at Atlassian. We used Jira in my companies. In this course, I think we're using a version, something that's in GitLab. They're all very simple ideas. It's just that what you're working on in your sprint is associated with tickets that are on a task board. I'll show you what that looks like. And then you use sort of whatever mechanisms possible to deliver your feature in the most efficient time. So you could do pair programming and all that stuff, and you want to handle conflict when it arises. And it does arise. It will arise potentially in 1531 and future group work, and it will arise in industry. And I'll give some examples of stuff that I battled with in industry. So I sort of described this milk voice. What does that mean? Anyway, I sort of described this a little bit. Yeah, what did I do? What did I face? What am I going to do? Stand-ups are really simple. You should practice having them in your groups for 1531. Maybe not every day because you've got 3 units, courses that you're doing, but something similar. Yeah, this is another interesting point. Sometimes now your stand-ups can be asynchronous. At some point we tried this. I remember we had a bot in Slack that would at 9:30 message everyone in the team and say, type your stand-up. Once everyone had typed theirs separately, it gave a report to everyone. This is an example of an asynchronous stand-up. But I think stand-up, synchronously is probably still a good idea. You want to be able to say, oh, hey, blah, blah. How are you going? I really need you to finish that authentication function. I'm stuck on that. Can I help you with it? Like, what do you need? May work for larger teams, blah, blah, blah. But yeah, blockers, it's not synchronous. You get the idea. Weekly meetings are longer than... a good stand-up is like 5-10 minutes, really quick. It's a bad sign whenever you start having stand-ups and there's always someone that wants to talk and talk and talk. That's a bad sign. Once a week, once a fortnight. Ideally for 1531, you should do this once a week in your groups. And you basically want to review at a higher level how the sprints are going. So, what are the themes of the stand-ups? Is some system crashing and causing you lots of issues? Do we need to refocus what we're doing in the next sprint? So think of it as like the next sprint planning meeting. Someone online said, Stack Overflow's down, our production's going to be delayed until further notice. That's pretty accurate. Pretty accurate. This is a screenshot of Jira. It's really hard to see. It's not very hard easy to see. But basically you just are describing the minutes in this screenshot of what you're talking about in these weekly meetings. You want to talk about who was there, did you have an agenda for the meeting, what you discussed, and really importantly, what are the actions? And you want to tag the users for each action. So if the action is, go and speak to vendor X about some product that's not doing what it should do, who's going to do that and when are they going to do it by? Okay, ticket boards. They are the bane of a developer's life, but they're very important. So a ticket board describes to you what it is you're doing in your sprint. Okay? Different companies do these things differently. When I was the last project I was working on, I think, in defense, I made my own tickets. So we would have our meetings and we would say, Jake, I'm going to work on this thing. And then everyone's like, yeah, that's good, that's a priority. And then I will go and make the tickets, maybe at the beginning of the sprint. And then as I work on them, I say, okay, this ticket's complete, or this needs to go to review, or this is blocked for this. And then I track my own tickets. That's one way of doing it. But we were a small team. In bigger teams that have more money, there will be dedicated people that create all the tickets, assign all the tickets, review, and track the life cycle. They may not be engineers, they may be product managers or product or scrum masters or something like that. Could be an engineer that's moving into more leadership. But they're not always technical roles. But they know enough about the product to be sort of dangerous. And very simply, you have 3 bins: backlog, to do, doing, done. That was 4, or whatever. You get the idea. And you just track everything that you're working on. And every ticket is assigned to someone. They used to be done on a whiteboard. In fact, I've had projects where we literally used a whiteboard. We're all around the whiteboard, and you literally move the post-it notes, doing to done, done to this to review. But then COVID hits, everyone goes online, so we have digital tools. So basically, it's very simple to do pretty much this. Very simple. You might think like this sounds like a whole lot of work that's not writing code. And it's sort of true. In some places they take it a bit too far. You need to know, if you've got a big team, you need to know what people are working on. And the whole idea of Agile is to just get people focusing on work. So these exist in GitLab. We'll take a look and we can use them to store and track your progress. For the project deliverables in this course, your tutor, when they're marking your project, will look at your board. And it's very simple and easy to tell, are you using the board authentically? If you go like, oh crap, the project's due in 10 minutes, I'm gonna just like fake activity, it's very easy to tell. You just look at when everything was last moved. But also, you can just tell, like you get a feel for what a real active task board or ticketing system looks like. What's really good about it, you have discussions on the tickets. Like it's really common to see tickets where you're like, at blah blah, like this isn't working, I thought this would be, oh no, this, you're doing this wrong, oh okay, gotcha, right? It's a form of communication. All right, let me find one on GitLab to show you all. What's a good one to look at? I'm going to pick a random group, I think. Is it here, I think? No. Does anyone remember who's done it yet? Which one is it? Okay, this is what it looks like. Does anyone know where the issues are? Oh, it's issues. Oh my God. Thank you. All right. So this project obviously hasn't started using them yet. That's fine. It's that simple. It's associated with a repository. Every repository on GitLab has its own issue board. Here's a more filled out one from the GitLab website. And this is a pretty good example of what a good issue board looks like. You can see every ticket is one of these square regions that you can drag around. You've got open, deliverable, closed. Like I said, every company is going to have slightly different nomenclature. What a useless word for me to use that. Every ticket should have who's working on it, when it's going to be delivered, and the status of it, things like that. And a description of what it should be. A really good ticket, here's how you know you got a good ticket. You read a ticket and you know exactly what code you should be writing. When you have vague tickets, that really annoys me. That sucks. When you got a ticket and you're like, fix login page. You're like, what? What's wrong with it? Oh, there was a CSS bug and then on dark mode, you couldn't see the login button. Okay, that's a better ticket description. So if you have really vague tickets, that's not very good either. You can add notes. Yeah. In the notes, I'm saying to do all that detail. Yeah. And another really good thing that I love to see in tickets is screenshots. Sorry. Okay. Screenshots in the tickets, like show what the problem is. Now, this isn't probably applicable to you because you're doing back-end this project, but on a front end, show what the visible error looks like if you can. You can't always, though. Any questions? Don't put a screenshot of code, but you can put the line and the file number. The file and the line number. You should be collaborating. Yeah. Yeah, absolutely. You need to work on a function together. Do whatever. There is a component where we want to see. You can't have one person in the group write all the code. That's a problem. But if I'm stuck on something and you should help me. Yeah. Sorry? Can you switch? Can you what? Help? Don't help other projects. What are you doing? All right. You just mentioned this. Pair programming is really good. Hold on. Sorry. I don't really. Okay. Work together in your team. If one of you is stuck on a function, don't be quiet. You know, say, can someone help me with this code? That's pair programming, is writing code together. Handling conflict. Speak to your tutor. Speak to me. There's no issue in all the offerings of 1531 that we've not been able to resolve. Yes, people get a bit annoyed, but it's a fact of life. Learning to deal with conflict is really important. Okay, that's the lecture. One thing I wanted to say, no one reminded me. Next week on Wednesday, there's a guest lecturer coming. Now, has anyone heard of Rob Pike? Has anyone heard the name? So this, someone say yes? Hello? Have you heard of Rob Pike? Rob Pike. So he was a developer at Google from Bell Labs before that, and he wrote the Go programming language. He's a very famous computer scientist. He's delivering the guest lecture on Wednesday. I'm very excited. What I want from everyone, maybe on the forum, I'll make a category, is to think about some questions that you would like Rob asked. And he's going to talk about next Wednesday his experiences writing large software projects at Google, Bell Labs, and writing potentially the Go programming language. If you've never written Go, go look at the language. It's very popular. It's very useful. I will post it on the forum. Yeah. Okay, that's the lecture. Thank you all very much. We managed to get through it, so thank you for bearing with me. Yeah, thank you. Thank you, everyone. I'll see you next week. I'll leave that up. That's fine. And any questions come up?
Related to group assignment and like weekly labs as well. So first question is like about the style. Do you mark like suppose I know a bit of programming, like I know JavaScript and everything. So is it okay if I like write an algorithm in using many functions and like making it shorter than some other guy in my group is doing exactly what is being done? So is it okay to have different?
Yeah, that's fine.
Or will it be?
We don't want every project writing the same code. So if you know some,
advanced
good practices, go for it.
Also, can I create helper functions?
Yes.
For like suppose.
I encourage it.
Yeah, because I did it for my weekly labs. So
remember, this is one of the reasons we do black box testing.
Yeah.
I don't care if you use helpers. In fact, helpers are a good sign that you're writing good code.
Yeah, because like if suppose my and other guys function within the function is doing something which is repeated in both of our functions.
Yeah, you should bring it out to help. In fact, to get a really high mark, that's one of the things we look for.
Yeah, that's like one of my concerns. Like, will I be marked down or something?
Cool. No. So yeah.
And also the third question is like, if I know some functionalities or some high-level programs dot functions, can I use it?
Yeah, of course.
Okay, because
you're a software engineer. Go impress us.
Yeah, because that was one point where I was marked down in 1.1.
No, we don't have any rules like that.
No, I was marked down in my assignment because I was using array and pointed.
Yes, I'm saying we don't have any rules like that in 1531. 1511 is very on rails.
Yeah.
All right, we have an idea. 1531 is you look.
Like,
But you don't want to take it too far though.
Yeah.
Like if everything's super complicated and we can't even understand it, that's not good.
I won't make it.
But if it's tasteful, it's improving.
Just to make algorithms shorter.
Yeah, of course, go for it.
Yeah. Thank you.
And if you have any issues, just let me know.
Yeah.
Like if the tutor marks you down or something, just let me know.
Yeah.
And I'll weigh in. You might not
And
be
also,
right.
can I help like the guy to
In your
understand?
class,
Yeah.
of course.
Okay. Thank you.
Just you did say just put if let's say for backend or something, but you just said put the
Yeah.
where the code is now.
Yeah.
Why can't we take a screenshot? Because like I feel like it's more easier.
Is it? I mean, what if the code changes after the screenshot's taken? What if the function's moved into another file? It's better just to give the name of the function so that what a developer will do is search the function name in the code base. The screenshot's not really going to help you.
Because like the screenshot's not gonna change it.
That's right.
And then like if they say
That's
oh,
right.
well,
What if I've got a really big file and I split it up into two files? Right? It's better just to give the name of the function.
oh right.
Not even the line number, just the name of the function.
But I guess like for front end